So in 8.1, we're talking about the geometric mean, and the geometric mean between two numbers is the positive square root of their, positive square root of their product. So what does that mean? Well, if we have two numbers like a and b, the geometric mean between a and b is the number x, such that a over x is equal to x over b. And if we cross multiply here, then we'll get a x squared is equal to a times b. If we solve for x, we're square rooting both sides, and so we get the geometric mean x is equal to the square root of the product of a and b. Okay. So here's an example. It's the geometric mean of a and b, where a is 9 and b is 4. Well, what do? We multiply a and b. We get 36, and the square root of 36 is 6. So the geometric mean is 6. Right? So how do we find the geometric mean between these two numbers? Well, it's going to be the x is equal to the square root of 12 times 3. And that's going to equal to the square root of 36. And that's going to equal to 6. And then we have the square root, the geometric mean of 8 and 4. So it's going to be x is equal to the square root of 8 times 4. So that's equal to square root of 32. And we could simplify this. So why don't we go ahead and simplify it? So we'll do a prime factorization. So it's 2 times 16. So 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And then we'll have that 2 there at the end. So we have 1, 2. So then 2 2's are going to come out. So this is going to be equal to 2 times square root 2. And then that simplifies down to 4 square root 2. Yep. And that's our geometric mean. And then you're going to be asked to solve these problems here and find the geometric mean between these pair of numbers. Why don't I just go ahead and move on to the right triangle geometric mean theorem. And what does that state? It states that if we have a configuration like so, where we have a right triangle ABC, and we have an altitude coming down, which we're denoting with the letter H, then we can create an equation which says the small section of the hypotenuse over the altitude is equal to the altitude over the longer section of the hypotenuse, right? Like so. And then we could solve that equation by cross multiplying. So the altitude is equal to the square root of x and y, or basically the geometric mean between the two sections of the hypotenuse, right? Okay, so that's one theorem where you can find the altitude of a right triangle if you have the values of the sections of the hypotenuse, right? It's going to be the square root of the product of the sections. So then we're looking down here. So we have the geometric mean leg theorem. This one's a bit different. If we have this configuration here, which is the same configuration, except we're not looking at the altitude, we are looking at the legs, we can create an equation which says the entire hypotenuse C over one leg is equal to that one leg over its adjacent hypotenuse section, right? The segment of the hypotenuse. So this segment is not adjacent to B, right? It's not touching B. So we're going to do hypotenuse C over B, the leg, is equal to the leg over the adjacent hypotenuse segment X. And you could use that same trick to find A as well. So we have C, the hypotenuse, over A is equal to A over Y, right? The adjacent hypotenuse segment. And then if you cross multiply that equation, then we'll get that the leg is equal to the geometric mean between the adjacent hypotenuse segment and the entire hypotenuse, right? Multiplied together. So we can use both of these to solve problems here. So here's an example. the example is find x, y, and z. So x is the altitude. So which of the theorems are we going to use? Are we going to use the altitude theorem or the leg theorem? Well, obviously the altitude theorem. So we're going to create our equation here. Our variables are different, so be aware, right? What does the altitude theorem state? It says that the hypotenuse segment over the altitude is equal to the altitude over the other hypotenuse segment. So that's the equation that we're going to create here. So the hypotenuse segment 5 over the altitude x is equal to x over the other hypotenuse segment 20. So here we go. And then we'll say x squared is equal to 5 times 20. So x squared is equal to 100. And then we're square rooting both sides, so we get x is equal to 10. And we're done with that one. Oh no, I'm not going to have enough space. So now we need to find y and z, the two legs. So which theorem are we going to use? Are we going to use the altitude theorem or are we going to use the leg theorem? Well, obviously we're going to use the leg theorem to find the value of the legs. So so this one is going to be, what is it? Hypotenuse over leg is equal to leg over adjacent hypotenuse segment, right? So if we're going to find y, it's going to be the entire hypotenuse, which is 20 plus 5. So we're going to get 25 over y is equal to y over the adjacent hypotenuse segment, jm, or 5, right? So we're going to say y squared is equal to 5 times 25 is 125. Square root both sides, and we get y is equal to, what is this going to be? So prime factorization of 125 would be divided by 5 would be 25, and then divided by 5 is 5. So we get this expression here, or these factors. So 1 5 is going to come out, leaving a square root 5. So it's going to be 5 square root 5 is our answer for y. And then lastly, we need to do z, and it's the exact same process. So it's going to be the entire hypotenuse, 25 over z is equal to z over the hypotenuse segment of 20. So we get z squared is equal to 20 times 25. Oh goodness, that's going to be 0 and a 5, so 500. And then we'll square root both sides, and we'll get z is equal to this. What is the 500? And in its prime factorization, let's do a 2. So 2 would turn it into 250. And then we'll do 5. That'll turn it into 50. And then we'll do a 2. That would be 25. And then the factors of 25 are 5 and 5. So 1 5 is coming out, and 1 2 is coming out. So it's going to be 10 square root 5. Yes. So I'm going to box that. Right. So that's how we're going to use the geometric mean theorem and the altitude theorem and the leg theorem to solve these problems. I'll go over the answers in the next video.